What your social media feed, your bank account, and your favorite streaming service all have in common. It's not the app, it's not the code. It's this one simple, really powerful idea that organizes all of their data. So let's pull back the curtain and see how your digital world actually works. To really get why today's systems are so great, we gotta go back in time. Think the 1970s. Back then, organizing data wasn't just messy, it was a maze, a total labyrinth of connections that made finding anything a real nightmare. And this slide really shows you what I mean. These were the two main ways they tried to do it. On the left, you've got this rigid tree structure, where every piece of data could only have one parent. And on the right, well, that's the network model, basically a chaotic spider's web of connections. Both of them were just incredibly complicated and really inflexible.
Let's make this real for a second. Imagine you're a bank teller, it's the 70s, and your customer, Sue Smith, wants to check a balance. You would literally have to trace a path through this data maze, following a link from her name to her accounts, then another link to her transactions. You make one wrong turn, and you are completely lost. It was slow, it was easy to mess up, and honestly, it was super frustrating. There had to be a better way.
And you know what? There was. A single, elegant idea that just cut through all that complexity and pretty much built the foundation for the digital world we live in today. So the big breakthrough came from this man, Dr. E.F. Codd. He was a researcher at IBM, and in 1970, he published this paper that proposed a totally new way of looking at data. And it changed everything. And this slide right here, this is his big idea. He just asked, hey, what if we forget all those confusing pointers and links and just organize everything into simple, clean tables? I mean, look at the difference. It's like a breath of fresh air. You go from total chaos to this beautiful, logical order. This was the big aha moment. This whole approach is called the relational model. And the main idea is that every single piece of information lives in a table, kind of like a simple spreadsheet. And you connect them, you create relationships, not with confusing pointers, but just by matching up common info, like a customer ID between different tables. So, for example, here's a customer table. See how simple this is? Each row is a unique customer, and each column is a specific piece of information about them. It's just intuitive. You can see at a glance that customer with ID number 2 is Sue Smith. It's simple, it's powerful, and it's so easy to understand.
Okay, so the data is now beautifully organized in these tables. That's great, but that's really only half the battle, right? How do we actually interact with it? How do we ask it questions and get answers?
Yeah, this was the next huge piece of the puzzle. It's like having the most organized library in the world, but it's useless if you can't actually ask the librarian to find a book for you. And the language for that is SQL, which stands for Structured Query Language. It basically became the universal standard for talking to these kinds of databases. You can think of it as the common tongue for all data. It's how we ask the questions and get the information. Okay, now this might look like scary computer code. I get it. But stick with me here because it's actually a lot more like a simple sentence than you'd think. See? All that query is really doing is asking a simple question in a very specific way. You select what you want, you say from what table it's in, and then you say where to specify which one. Once you get that simple pattern, it's incredibly powerful. You can ask really complex questions with just a few lines of this. So we've got our neat tables, and we have a language to talk to them. But the true genius here, the thing that makes this whole model so powerful, is how it connects information between all those different tables. This is where the real magic happens. So let's say we want to know what kind of account Sue Smith has. Well, her name is in the customer table, but her account info, that's in the account table. We need to link them. And SQL has this amazing command called a join that does all of that work for you, instantly connecting the dots across tables to give you one clean answer. This is the superpower of relational databases. Okay, so let's zoom out for a second and see how this amazing solution, an idea from over 50 years ago, isn't just some abstract concept. It is, quite literally, the engine that runs our digital lives. Every single time you scroll your social media feed and see posts from your friends, that's this model working. An online store that remembers what's in your shopping cart, that's the relational model. A streaming service recommending a new show you might like. You guessed it. It's all just tables of users and posts and products and movies, all being joined together by SQL to create your own personal experience. So next time you're using your favorite app, just remember, underneath that slick design, your information is sitting neatly in tables. This whole model is so reliable, it's been the foundation for decades. Now, sure, for the massive, messy data of the modern internet, we've developed new kinds of databases. You might hear the term NoSQL. But for the core transactions that run our world, it all comes back to this one brilliant idea. So you see, SQL is so much more than code. It's the language we use to have a conversation with data. It gives us the power to ask incredibly specific questions and get precise answers from just oceans of information. Which really makes you wonder, doesn't it? If you could ask any question of all the world's data, what would you ask?